Just wait, don't scroll down. Now, this is Menora Academy by Pastor Ogo Kenneth, and I'm here to break down mathematics for you. Mathematics is made easy at Menora Academy. We're on YouTube. Just search Menora Academy by Pastor Ogo Kenneth, and you will be directed to the channel that have a lot of topics in mathematics, and you will enjoy it. Remember, when you are playing this video and it is not clear on your screen, you can go to the setting icon on your screen. Go to the setting icon on your screen of where the video is playing, and then tap it. Go to advanced, tap quality, and then increase the quality. Maybe only 700 and something before. You can take it to 18 something, or if you want it below 700, and take it to 700 just to give you a better view. Alright, but if it is giving you a clear view, there's no need of doing all the setting. Alright, so thank you very much. Don't forget to subscribe. Don't forget to like. Don't forget to share. Subscribe now. It doesn't bite. This is a dream come true for all parents, for every student. Menora Academy is helping life. Follow us to the next mathematics that we have for you. Today, I'll be sharing with you Trigonometry 2. Now, Trigonometry 2, under Trigonometry 2, we'll be looking at Pythagoras theorem. What is Pythagoras theorem? It's just a theorem that tells us about a shape. Alright, tri means a shape that has three sides. That is what tri means. Alright, so now we have our ABC, this triangle ABC. Now this triangle, we have the small side of the triangle too. So trigonometry is saying that the long side, which is the hypotenuse side, squared, notice the right angle triangle, the long side, which is the hypotenuse side, squared, is equals to the sum of the two remaining sides, the square of the two remaining sides. Alright, so this is the sum of the square of the two remaining sides. Okay, so what it simply means is that line BC squared is equals to line AB squared, and then plus line AC squared plus line AB squared. Alright, so A squared is equals to B squared. This is our B, this line B. Okay, so equals to what? Plus C squared. Alright, so we have an example. How do you apply it? Now, in the diagram below, solve for the value of SR, line XR. So now this is the diagram. Alright, so we want to find this particular space. This is our SR. Now, before we solve this problem, you will agree with me that a triangle PRQ. Now, this is the right angle triangle. We can say that we can find our PQ first. Find our PQ first. Alright, so that you can be able to find this place. Alright, so triangle PRQ. Now, this PRQ, what we have using Pythagoras theorem, our line PQ squared, this line PQ squared, the long side, the hypotenuse side, is equals to RQ squared, then plus line PQ squared. You see, this is our Pythagoras theorem. The long side squared plus this side squared plus this side squared. Alright, so PR is given to be 13, so it's going to be 13 squared. So be equals to RQ. Our RQ is going to be 5 squared. Then plus PQ is what you are looking for. So we don't know it. PQ, like PQ is this square. So 13 squared will give us 169 equals to 5 squared is 25. Then plus PQ, like PQ squared. So we collect like 10. So we are going to have 169 minus 25, because if 25 is causing the sign of this inequality to this left hand side, change to minus 25 equals to PQ is left. PQ squared is left. So now that we have PQ squared left, so 169 minus 25 is going to give us 144 to be equals to PQ, line PQ. Alright, so now that we have this, so therefore we take the square root of both sides in order to clear this square. So this is the square root of both sides. So the square root of 144 is 12. to be equals to this square will cancel this, so we are left with what? PQ. Line PQ is equals to 12. So what it means is that therefore our PQ, line PQ is equals to what? 12. Now this is not where we are stopping yet. Now that we have found this place to be 12, we can now be able to find our SR, because that is the target. Our XR is what they ask us to find. So therefore we can use the whole of this triangle now. Okay, consider in triangle PSR now, all of the triangle put together, that is PSQ rather, in triangle PSQ. Okay, in triangle PSQ, know that our hypotenuse is here. Alright, this is our hypotenuse. So we are going to have our PX squared and PS squared to be equals to, then our adjacent is here, SQ, equal to SQ, line SQ squared, then plus our, we have this particular side, which is our PQ, or our PQ squared. Now our PS is given to be 15. Our PS is 15 squared. Our SQ from here down to this particular place, we don't know it yet, so we leave it as SQ squared. Then plus PQ is what we just found to be 12 squared. So 15 squared will give us 225. Then plus our S equals to our SQ. Our SQ we don't know, plus 12 squared. Our 12 squared will give us 144. So now we collect like term. So collecting like term, we have 225. If this plus 114 is coming, change to minus 144 rather, to be equals to SQ all squared. So now 225 minus 144 will give us 81 to be equals to SQ squared. So therefore, we take the square root of both sides. Our SQ now will be equal to this, the square root of both sides. Square root of both sides. So square root of 81 is 9. So our SQ now is 9. So now the question is, we should find our SR. If we are going to find our SR, if from here down to this place, from S down to Q is 9. Alright? That means this particular and R to Q is 5. That means SR plus RQ is equals to SQ. That means this small space plus this space, all of them put together will give us from here down to this place. Now this is what I mean. But our SQ, line SQ is equals to what? SR, line XR, then plus RQ. So line RQ. So our SQ is 9. SR is what they asked us to find. Then RQ, our RQ is 5. It's given to be 5. So we collect like 10. Our SR, line SR now equals to 9 minus 5, which is equals to what? 9 minus 5 is equals to 4. So you discover that this particular SR is equals to 4. So look at this example 2. Example 2 says we should calculate the length of the altitude of an isosceles triangle whose base is 24 cm long and whose equal sides are 13 cm long. Now, isosceles triangle is the kind of triangle that have two sides equal. Alright, two sides of isosceles triangle is equal, something like this. This is an isosceles triangle. Okay, so now let me draw it so that to look exactly like an isosceles triangle. Okay, so now that we have this is an isosceles triangle. You can see this is A, B, and C. Alright, so this side and this side are equal. Now they say the altitude. Altitude means height. Okay, this is the height. This is the altitude. They say calculate the length of the altitude. Alright, so they're asking us, let's say here is O. They're asking us to find AO, okay, of an isosceles triangle whose base is 24 cm. The base is 24 cm. That means here is 24 cm. That means from B to C is 24 cm, and then the long, whose long and equal side are what, 13 cm. So each, this is 13 cm. Here will be 13 cm. Now, how do we get the altitude now, which is the height? How do we get this altitude, which is the height? We have two right angle triangles in this shape now. Now that we have this right angle triangle, two right angle triangle in this shape, we can actually find the altitude. How do we find the altitude? Now, if this particular place is 13, here is 13, and from here to this place is what? Is the base, and this is the height. You will agree with me that the height of this will divide BC into two equal parts. Yes. So therefore, what it means is that by the time this, if the whole of this place is what, 25, and this is the altitude, the height, that means here will be 12 centimeter, and here will be 12 centimeters. So by the time you use your Pythagoras theorem, you are going to get your AO. Okay, so remember Pythagoras theorem says that the hypotenuse side, we can use any of these triangles. So let's use in triangle ACO, triangle ACO. Let's use this right angle triangle at the right hand side. So what it means is that our hypotenuse side is AC, line AC square equals to, you see, this our adjacent side, which is OC square, then plus our opposite side, which is AO, and that is what we are looking for. Our AO is what we are looking for. So our AC is 13, so it's going to be 13 square, so be equals to our OC is 12. All right, so that is 12 square. Then plus our AO is what you are looking for. AO is the altitude. Altitude means height. All right, so now 13 square. Our 13 square is 169. Then equals to what we have next is now 12 square. 12 square is 144. Then plus our AO, line AO square, is what you are looking for. So we collect lighting. So 169, if plus 144 is coming, change to minus 144, then equals to AO square. Then we have 169 minus 144 is going to give us 25. And 25 is going to be equals to AO all square. So we can take the square root of both sides, so that this square will cancel this square root. Therefore, we are left with what? AO, line AO, square root of 25 is 5 centimeters. So the altitude of this particular height is going to give us 25 centimeters. So this is how to use Pythagoras theorem